What's up, guys? Today will be lesson 10.4. It's pretty easy. It's about inscribed angles. Inscribed angles are angles inside a triangle. I mean a circle, sorry. Inside a circle. Not at the center. That's going to be something different from the other notes. Alright, so let's go over this inscribed angle stuff real quick. So I have two different circles here to go over the same property but twice. So let's say this angle right here, no, this one over here, this one is, I don't know, 40 degrees. This angle D, or angle ADB or BDA, however they name it, angle D is the same thing as angle ADB, the same thing as angle BDA, whatever. That angle 40 degrees, it's not in the center. Before, all our angles were in the center. Not anymore. They can be in the center or on the actual circle on the side. This is called an inscribed angle. It's inside the circle. So the problem is when we're trying to find the arc, because the whole point of this is to follow the angle. Follow it up here and follow it down there, because it makes the angle right here. I mean the arc. See the arc AB? So how much is this arc AB? Well, arc AB is 2 times as big as the angle, the inscribed angle. Inscribed. So this is 40, that's 80. So our arc AB is 80 degrees. And vice versa. Let's say from here to here, from A to B is, I don't know, 120 degrees. That's the outside arc. So the outside arc AB is 120 degrees. Angle D is question mark. Well, over here, when you're on the inside, you times 2 to go out. So times 2 and you get that number. Over here, when you are on the outside, you're just going to divide by 2 and it gives you that number. So 120 divided by 2 is 60. So angle D is 60. Real simple layman's term, if you're on the inside, multiply to go outside. If you are on the outside circle, divide to go inside by 2. That's it. Times 2 to go out, divide 2 to go in. Real basic, simple. And something like this is one of the many ways they will try to trick you. Now, I'll work for this one first right here. Here's my arc. You are on the outside. The outside is 60. So if I wanted to come back inside, you divide. To go in, you divide. So that's 60 divided by 2. This is 30 degrees. And just in case you're wondering, you follow these lines and that's how you figure out which ones go together. So like over here, the 37 is the angle right here. You follow it there and down there. So this arc belongs with that 37 degrees. They belong together. This is on the inside. To go outside, you have to multiply. Over here we divided. by 2 to go in. Here to go out, we're going to times 2 to go out. Alright, so 37 times 2, or double 37, which is 74 degrees. So, well, arc QS is 74 degrees, and angle S is 30. Remember, they don't call it angle S, it'll be angle RST or angle TSR, same thing. And then they're gonna get real fancy and go over stuff like, remember, all this makes 180 from here all the way here. Subtract from 180 and it'll give you this piece right there, and vice versa, but I'm not doing that right now yet, in this question at least. Alright, let's look at this question here. I'm gonna do a lot of stuff with this one question real quick. Well, the first question I want to know is, how much is arc HJ, and how much is angle HGJ? So first the arc. So let me see. HJ is right here. Starts here at H. So let me follow it in. Here's my J. Let me follow it in. There you go. The 39 belongs to this arc. Even though there's something in the way, it doesn't matter. This 39 belongs to this HJ. We are in the inside. How do you go out? Times 2. So times 2 gets me outside over here. 39 times 2 gives you 78 degrees. So from H to J, that's 78. Now the cool thing here is we want HGJ. HGJ. Okay, so here's my H, goes to G, J. Okay, so G, follow it, right there, and my G goes down to J over here, and it's the same arc. You have two different angles, but they intersect at the same arc. And that happens, no big deal. That's 78 for the red angle, and it's still 78 for the purple one. But how much is the angle? To go inside, we need to divide by 2. Divide by 2, which gives you 39. $39. So two different angles in different locations, but the same arc. It happens. Now let me erase this real quick. Hold on. Right, so we know this is 39. And we know this is 78. You got that. And don't forget that this FH is a diameter. So is GH the other direction. Just depends which way you want to use it. Why do we care about diameters? Because they cut the circle in half. So we look at it like this. From here to here is 78. How do you figure out how much G to H is? Well, if that is cutting the circle in half, all of this should be 180. So then we're going to subtract 78 from 180, and it'll give us the answer. 180 minus 78, which will give us 102. So from G to H, 102 degrees. I think you have to do it on your work. But anyways. Alright, 2 more things and we're done. So let's see this one. So here's an angle right here. Here's my angle B. Angle's right here. The problem is you're trying to figure out how much is angle B and there's no numbers at all. So you're like, what the heck, Mr. Gomez? How do you do this? So you see that here's the diameter, A to C. But first, outline this angle. Remember, here, all the way down there, to all the way here. What arc? What arc is that? Well, that arc is from A all the way to C. And if you notice, the red part makes half a circle. And half a circle is 180 degrees. Boom. There's a number that wasn't given to you, like magic. So, we're outside. How do you go all the way back in to get the little baby angle? Divide by 2. 180 divided by 2 is 90. So angle B is 90. So there was answers all over the place without even having numbers, like ninjas. Alright, and the last thing we're going to go over is they're going to ask you a question. For example, can you have this shape, I don't know, this trapezoid or this kite or this rectangle or this octagon or whatever, can you inscribe it inside a circle? In other words, we got a circle, and can you put that shape inside there? I don't know. Just because I drew it all ugly doesn't mean it's going to fit. So, there's a rule. This is the rule. A quadrilateral can be inscribed in a circle if and only if. Oh, and that's the good stuff right there. If and only if and only if. Its opposite angles are supplementary. So 2 key words there. Opposite angles, if you remember what they mean, and supplementary. First, opposite angles. Here's D. Opposite would be way over here. So D and F are opposite. Angle E, opposite would be way over here at G. So they're pretty much saying that if you get angle D and you add it to angle F, you get supplementary, and supplementary is 180. Same thing with E and G. Angle E plus angle G are 180. Why? Because if my lines weren't so quick, they'd go through the center and they would make a diameter. Alright guys, that's it. Laters. Thanks for watching the video.